I don't have access to the LMS system. Well, I still don't have an email for it yet. Okay, so are you waiting for the emails? Didn't they give you the training document or your access emails as yet? Okay, I'm sure you'll get it during the week. You'll get it during the week. And how's physics for you? How are you finding the subject physics? Is it difficult? Is it easy? How is it for you? How's physics for everyone? Or maybe at this point you just want to pause it and leave it alone. How's physics for everyone? How's physics for everyone? Okay, guys, let me introduce myself. I can see everyone is here. Hello, everyone. I am Miss Ngunyulu and I am your new tutor. Hi, everyone. Hi, guys. I saw someone in the group asking me if I'm the new physics tutor. Yes, I am. My name is Miss Ngunyulu and I will be your physics tutor from now on. And I'm excited to be here with you guys. Feel free to talk to me. Let's work with this subject together. And I'm sure I'll be able to help you guys to enjoy it and to also pause. But if only you guys meet me halfway. So, yes, I am your new physics tutor. And I'm so excited to be here with everyone. So, yeah. So, what did you do from your last lesson from term 1? Do you remember what was your last class about? Guys, can you see my screen? Hello? Can anyone see my screen? You need what? Okay, thank you so much. I didn't see that. But in the last few lessons, we went over the test but never finished. Yes, ma'am. Okay. So you went through the test that you wrote in first term. Ma'am, what's your teaching style going to be? That's a very interesting question. What I'm planning to do, I want you guys to interact with me. I have different teaching styles that I can use, but it depends on what you guys understand or what you enjoy the most, what's easy for you to get. Like today, I have a summary of plastics and polymers, and then after that, we will discuss questions together. So I really like when students tell me questions they don't understand and then we go through them. And if there's a concept you don't understand or the summary you don't understand on plastics and polymers, we go through that. But what teaching style will you prefer or you like, Chloe? Because I'm very flexible. I do anything that the students are satisfied with. So we go through the summary of that topic and then we do more questions so that you are able to you are able to answer any questions you come across. Basically, getting I want you guys to understand the concept and how to to tackle different questions that you can meet on the test on in the exam. But is there any teaching style you guys would prefer, or is there any way you guys would prefer us for us to work together? Please talk to me. Yes. Okay. Yes, there will be pre-recorded videos that will be on the LMS system. That's the theory part where you will need to go through before you come to class. And then for me, I'm just going to do the summary of those theories, the concept that you need to take note of, and then we do questions from there. So that's how it's going. It's still going to work the same. And but the only thing is that the pre-recorded videos you will only get them on the LMS system. And then and another thing I'll ask from you, if you are doing a question and you don't understand, and maybe you're doing it at night or anytime and we don't have class or we're having class later on that week, you can send it to me and say, ma'am, I don't understand this question. Can we please do it in class, or can you help me with this question? I think that will also help with, because we're not limited to the questions we'll do in class. And also I have homework, so I'm going to give you guys homework. There's already homework for this week, but I'm sure it will be posted on the LMS system so we can do the questions together. So okay guys, we can start now with our lesson. Today we'll be doing plastics and polymers. I'm sure from your previous class you were doing the addition, elimination, and substitution reactions. So today we continue with the next topic, which is plastics and polymers. So as I've said, we're going to do a summary. This is the summary of the whole section or the whole chapter or that topic. We know that a polymer is a micromolecule that is made up of we did not cover the types of reactions. Okay, where did you end for your last term? Let me find out that to be sure. What was the last thing that you did? It was the naming of organic compound. Wait, let me get what you're saying. You did the naming of? Yes. Not in great detail. So you would like us to go back to the? You didn't cover it at all. Okay. Okay. So you haven't done the addition, substitution, elimination. Did you do esters? Okay, and were you given the pre-recorded videos of addition of the reactions basically? No, on the Google Classroom. Because I think the last one I saw it was on like on the addition elimination. So I thought you guys did it, but since you're saying you only did, so we're going to start with the addition, elimination, and substitution reactions, and then we go down. So you didn't do the halogenation. You have no idea what those are. Okay. Okay, I think I know what's going on. I was not aware of that because I thought you guys covered it. Um, so you know what we're going to do? We have another class when? Tomorrow. Can we do those reactions tomorrow and questions? And please, if you can, please go watch the pre-recorded videos of those reactions. They're pre-recorded, so we'll do questions tomorrow. Right, so today we'll continue with polymers, so we will be working backwards, but we'll go forward once we've covered the things that because I want to make sure you guys have covered everything. I don't want to skip anything because I was not aware of that and I was not told, but it's okay. I'm going to cover it with you guys. So to be clear on what you are saying, you're saying you only, the last lesson you had was on the naming of compounds. So now we need to do the addition, subtraction, and elimination reactions. Okay, so okay, that's great. So what I can say to you guys is today we're going to do plastics and polymers, right? It might help us to understand some of the reaction. I think there's 2 reactions that you will need to take off in the polymers. And then tomorrow we'll go with do the reactions in detail and do more questions. So now we'll do this week, meaning we'll do all the reactions and cover all the work so that we start on the term 2's work while we've covered everything. Is that okay with everyone? Okay, so today let's do polymers. Let's use the time we have to cover the plastics and polymers. So a polymer is a micromolecule that is made up of many repeating structural units called monomers, which are joined by covalent bonds. So a monomer, it can be your alkene, it can be your like the smallest compound you can think of, which means that a polymer, you just add two alkenes together, you get a polymer. And polymers that contain carbon atoms in the main chain are called organic polymers. So polymers basically that have carbons in them, and we know most of them as you've done the compounds, alkene, alkanes, alkynes, they all have carbon atoms. So those that have those carbon atoms in the main chain, they're called organic polymers. And organic polymers are divided into natural organic polymers, which are natural rubber. So basically polymers are plastic. Like polymers are plastics, and they have different namings. So you know that there is natural organic polymers or synthetic organic polymers. This can be, for an example, natural rubber or polystyrene. And the process that is used to form these polymers are called polymerization. And there are these are the reactions that we're going to cover. And from this part, you will understand what this addition and condensation reactions are. 2 examples of polymerization reactions, meaning you can add these monomers. These are your alkenes, your alkanes, but most of the time it's alkenes. When you add them together, that will be an addition reaction. So you adding Let me write somewhere. You adding this, you know it has hydrogens, right? Plus another alkene. When you add them together, you can add two, you can add, it doesn't matter how many alkenes you add. When you add them together, you will get a polymer, right? And this is where you have an addition reaction. So the addition reaction, it means that it will break one bond for the carbon to bond with the other one. And the same will happen to this carbon. It will break one bond to bond with the other carbon. Hence, it forms the polymer. So we know that the process to form the polymers is called polymerization, and it can happen in two reactions. It's either addition or condensation reactions. And we are told that addition polymerization occurs when an unsaturated monomers such as alkenes are added to each other one by one. So this is an example of addition polymerization reaction. So it gives an example. Okay, this alone, an alkene alone, is a monomer, but when you add them together, you get a polymer. And this polymer, the name of the polymer you're going to get is called polyethane. There it is. Let me use a red. You will get a polyethane, because why? You added the ethene alone. I'll put two ethene monomers to form a polyethane. So these are examples of addition polymerization. So you can have polyethane, you can have polypropene, you can have polyvinyl chloride, you can have polyvinyl acetate, you can have polystyrene. All these polymers are formed through addition polymerization. I hope now you have an idea. When I talk about addition reaction, it's when you add, like for an example, two alkenes together, and that's what addition polymerization is. And the other reaction that can occur during polymerization is called condensation polymerization. This is a reaction. In this reaction, condensation, you must take note that a water molecule is released as a product of the reaction, and the water molecule is made up of atoms that are being lost from each monomer. So knowing the compounds that you will be working with, if you have an alcohol with an ester, when there's a reaction between them, the byproduct can be water. And in that case, it shows you that water has been lost, and you just automatically know that that's a condensation polymerization. So every time, in this case, you saw on the first, the addition polymerization, you are only adding alkenes. It can be identical or different alkenes. You will get a polymer. And also it shows that even if you have other functional groups in the compound, you can add them, and that happens to be condensation. So you can have polymers that have carboxylic groups in them. You can have them as they have the OH. So it depends on which reaction it is. So the examples of those polymers that are formed through condensation reactions are called polyethylene terephthalate and polyatic acid. These are polymers that are formed through polymerization, condensation polymerization. Any questions on this polymers, the summary that I have? Or maybe you're still confused, you don't understand the addition, you don't understand the condensation. Any questions before we do like few questions? So you have an idea what polymers are, that polymers are made out of monomers, and monomers are the smallest units you can have. Okay, no question. Great. So let's do some questions. Um, is the following reaction an addition or condensation polymerization? So we have a compound one. This is the monomer, and this is a monomer, right? And through polymerization, it forms a polymer. So what do you think? Is this addition? Is this condensation? From what we just discussed in the previous slide, what do you think what reaction happens? Addition. Okay, someone else? Addition. Others, what are you thinking? Addition reaction. Okay, that's interesting. So, in this case, it's not addition, it is condensation polymerization. And this is why. Remember, we said when there is a condensation polymerization reaction, a water molecule is released as a product. As much as you can't see that there is water, but there is water that was released. If you look at this compound, you can see that it had an OH, right, which was bonded to the carbon. And in this case, you had OH from this side, which was bonded to this carbon. But when you go to the polymer, you can see that something happened here. Is that addition, or as you can see here, only H was moved and here the OH was gone, meaning here we have plus the water, H2O. Here also the H was gone. It was not the OH. The O is still there. So you see what happened. Let me erase this. This will confuse you. As you can see, there's something missing. Like OH here is gone. And here, the O. And it formed the bond, right? I knew something was off. Yes, so this cannot be addition. It has to be condensation polymerization. So as you can see that here you had C double bond oxygen, which was bonded to OH. The H here is gone. And here you had OH, and you have there's 2 carbons with 4 hydrogens. So ma'am, they won't always show the water. They won't show unless it's when we do the reactions. In the reaction, you will see it if they want you to identify if it's condensation. But they won't always show that is the water was released. You just need to figure it out. So you knowing your type of reactions, it will be easier for you to identify. Like here, this cannot be addition because there are some molecules missing from the monomers, which means that hence water was released. So do we understand, guys? Are we together? Okay, next question. Is the following reaction addition or condensation polymerization? Let's look at it. This is it's a sign to show this is a polymer, and this was the monomer that was used. As you can see, this is an alkene, and it has some like a certain functional group there, but this is the polymer that it was formed after polymerization. So do you think this is addition or condensation polymerization? What do you think? What happened here? Anyone? Can you guess? Just look at it closely. What happened? Was there water lost? But from this question, it clearly gives you an answer. As you can see, it's not yes, it is addition. Because as you can see, this is an alkene. It has 2 double bonds, meaning this is an alkene. It just have a functional group. So in this case, as you can see, meaning these were polymers added. Three polymers were monomers were added, sorry. This, it comes from this. You just break one bond, you bond it to the other molecule compound, you just bond it to the, so hence this was addition polymerization. Do you see the difference, guys? Do you understand that in this case, when you have a two, like a double bond between the carbons, it can be addition polymerization. But if in this, like this case, you have two different or the same compounds, and when you go to the polymer there's something missing, it gives you a clue that is condensation polymerization. Any questions, guys? Any question? Do we understand? Are we together? Okay, I think today we're going to end there if you guys don't have any questions. And I hope tomorrow we'll deal more with the reactions, addition, condensations, reaction, substitution, elimination, so that you guys may understand the polymers more. So thank you everyone for joining our class today, and I hope you have a great day further. And if you have any questions, please come with them tomorrow while you are going through the elimination reactions, so that we can do them tomorrow. So bye, guys. Thank you, ma'am. It was nice meeting you. Bye, guys. Have a nice day further, everyone. Enjoy your day, everyone. Bye.